Okay, good evening, students. Now we just go to the last lesson of the syllabus, New Trends and the Future Direction in the ICT Unit 13. Now this is bit easy lesson actually. Now today I just revised this lesson and then probably another day I'll discuss all the past papers related to this one. However, remember this is bit easy lesson, just some theoretical parts you just understand and then easily you can answer the question in the exam papers. So initially you should know about the intelligence. So basically what is intelligence? Intelligence is the ability to think, to learn from experience, to solve the problems and adapt to the new situations. So basically we know that intelligence means if someone can think and someone can take some previous experience to solve some problems, which is we call as intelligence. So for that, actually, we should be able to get the knowledge and use that previous knowledge when you come to the new situations. So intelligence is very important actually, because based on that, that will impact on the human behavior. So people can get the or improve the intelligence by education, but because of the poverty, sometimes this intelligence will be reduced. So basically, you need to understand what is intelligent. Basically, intelligent means you should be able to think and make some decisions based on the previous experience and the previous knowledge. When it's come to the new situation, you should be able to apply that knowledge previously have learned to solve the problems. That is basically intelligence. Normally, humans are having that intelligence. However, we want to develop the same concept in the machines actually. We know that machines something doesn't have intelligence actually. So the artificial intelligence is a very wide range of area in the computer science. So basically we want to develop the machines which can work as a human. So as you know that currently the computers cannot think, but people wants to develop the machine so that the machine also will be able to work as a human, makes its own decisions and develop some intelligent systems. As an example, we know that already some research works done to develop the autonomous vehicle. That means without driver, now the vehicles can move in the roads actually. So that the system should be able to work as a human, even there is no driver inside the car. It should be able to move in the roads and should be able to identify the obstacles or other vehicles. If there is going to be have accidents, how to make some preventions, like just like a human take some actions while they're driving the vehicle. Now people are developing some autonomous driverless cars actually. So that is basically how you can build the intelligence into the machines, so that the machines can take the decision itself and make more intelligent systems. So that is basically artificial intelligence. Yeah, we want to build the intelligence in the machines so that the machines can work just like human, and most of the works can be done very fast and very quickly with the machines. So then that is basically artificial intelligence, where we want to build the same intelligence inside the machines by using different technology. So in artificial intelligence, mainly we must have these components actually learning. So we know that if someone is intelligent, he should be able to learn. So then that ability should be there in the artificial systems actually. Should be able to learn and reasonings. That means when it's come to the new situation, we have to logically think and make the reasonings and make the good decision based on that. And we should be able to apply the previous knowledge to solve the problems. And language understanding. So that is also part of the intelligence actually. We know that different people can understand different languages. It is also kind of intelligence. Recognizing the speeches and identify the images. So we know that as a human, you can identify the images and you can recognize what it is. But the intelligence systems, machines also, we want to do the same thing. Like as I mentioned previously, driverless car should be able to identify the obstacles that are there in the roads and make the necessary actions immediately when when the accidents are going to be occurred, you have to make some quick decisions. So for that, you have to recognize the whatever the things that are there in the roads and make the necessary reaction should be done very faster, very quickly. So whenever new situation occurs, you have to make the changes because it should not work with the predefined way. Actually, we have to get some new situations and then have to apply the previous knowledge and solve the problem. So that is basically artificial intelligence, and these are the key components of the AI. When it's come to very early, actually, this AI is very uh, earlier. This was there actually in the traditional AI. So initially, this AI initiated with this natural things actually. That is, people were initially thinking how our brains are working, like 1950, 1970 time period. They have mainly look at our brains actually, because humans are the one who has intelligence. Therefore, people are thinking how our brains are working. So therefore, they thought if you can model our brain inside the machine, then the machine also just works similar to our brain. So in that case, we know that our brains have the neurons, and they are the one who are storing this data and then process and makes intelligent decisions. So the same concept was developed in these neural networks. So that was the one of the very earlier concept people are thinking to develop the intelligent systems. They have identified or how they have studied how our brains are working. So they wanted to develop the same thing inside the computer. That is the concept behind the neural networks. Just keep in mind, which is very old one. But remember, in the nowadays we are going to discuss about this deep learning. So that is also basically based on these neural networks, artificial neural networks. So that was the concept they are using to recognize images or identify some characters, like we are using this artificial neural networks. That also same concept which was developed very earlier, called as neural networks. So basically they are working in the same way our brains are working. So that they were thinking how to develop the same concepts in the computer. So we have neurons in our brains, and they are the one working as just like a network together, and then they wanted to model the same thing inside the computer. That was the concept they have used actually as a neural networks. So that in general, when you take the input output relationships, when you have the inputs and the outputs, those can be related very simple linear equations. But here actually some relationships between the inputs and outputs are very complex, non-linear. In that case, we can build the relationship between inputs and outputs in a complex situation or very nonlinear situation using these neural networks. So this can be used to solve very complex problem or real world problem can be solved using this methodology that was initiated very earlier, but now also using this one by making artificial neural networks. So then after that, actually, what was the trend was the machine learning. So machine learning is the one which is very famous nowadays also. Idea is that we want to train the machine based on some data sets. And then we initially train the machine by inputting large number of data sets, and we can find out the patterns actually. So once you identify the patterns, what happened when you input the new data sets, computer can identify it actually. So that is what now you can see nowadays. If you look at this weather forecasting, not like early days actually. In early days, weather forecasting we don't accept actually. When we are here that weather forecasting, we will not we have not accepted it early days actually. But now you can see in the weather forecasting, if they say that tomorrow you're going to have raining, definitely you will have raining. So, and they can tell exactly what time, what location, how much you're going to have raining. That is because of the machine learning techniques. Their idea is to learn the previous data sets. Using the data sets, you can properly train the machine. And then when you have provided new data sets, it can detect what it is actually easily. So that is what we can do with the machine learning. So this will be used in many areas, the machine learning techniques to train the machine using data sets. After that, when you insert the new inputs, the computer can recognize what it is actually. So some disease identification for some of the plants. What you can do is you can get the images of the plants that has the diseases and train the machines. And then when you input a new plant images, you can find out whether it is going to have a disease or not. The computer can decide it by training the previous data sets. So basically here it's a kind of big area which has used some analytical methods and some mathematical methods. Idea is to train the computer based on whatever the data we input, and then make some decisions, when identify some patterns and make some decisions. So that is true. Just keep in mind, basically that is working with the data sets. So that is another area we had. And the nowadays we are working with mainly this AI with the deep learning. So basically deep learning is a subset of this machine learning actually. As I told you, this is mainly working with the neural networks, as I mentioned previously. So we know that this neural network is one of the way to identify some images or make some predictions can be done very easily. So then one branch of the one subset of the machine learning is the deep learning. Yeah, basically that is working with the artificial neural networks. So neural network, as I told you previously, it's a kind of human brain modeling actually. So therefore, which can recognize some of the things very easily and very correctly or accurately. You can identify something, identify some images or face recognition, voice recognitions, like those can be done using this deep learning. So just have the idea, but no need to memorize everything, but just have idea about what are those things. So when you take the key areas or key branch of the artificial intelligence, as I mentioned, deep machine learning. So there the idea is to train the machine based on data sets and then identify something. As an example, email spams. We know that there are some emails you get large number of emails. Once you train the machine, you can find out what emails are good, what emails are bad actually, or we call as spam. So that can be implemented in the machines automatically to detect the good emails and the bad emails. That is based on the machine learning. And as I mentioned, deep learning is a subset of the machine learning, but which is mainly working on the neural networks, artificial neural networks. Basically, you can use the face recognition, image recognition, voice recognition, like very complex parts can be recognized using these deep learnings. And natural language processing is another very important one. That is the one where you are using this chat GPT or translations. That is working in NLP, natural language processing, where it should be able to understand our language and process it and make some useful outputs. Computer vision is another key aspect actually in the artificial intelligence, where we should be able to understand the images, or example is a face recognitions. Now, face recognition is not easy task. Why? Because our faces are not changing dynamically, time to time. It is changing actually our paces. It is not the same pace today I have. It will not be the same pace tomorrow. It is changing actually. In that case, computer should be able to identify those changes and identify that person as the same person. So it is not easy task actually. So that is another key area which is used in the intelligence systems. And we know this robotics, heavily this research works are going on to develop these industrial robots that can be used in the machines. That machines can be used in many areas, manufacturing, agriculture, like many areas these robots can be used. And expert systems for the doctors, so they can use some AI tools to make some decisions. So we can develop the intelligence systems to replace the doctors actually. And speech recognition is another key area. We want to identify the person's speech and make some decisions. Like in the cybersecurity area, so some problems we can use this speech recognitions. Like these are some key branches in the artificial intelligence. When you take the difference between the machines and the human, We know that as a human, we recognize or we remember something based on the patterns. You know that some telephone numbers you can remember easily. Why? Because it has a pattern. That's why some organization, when they are making advertisement, they use the telephone numbers that can be easily remembered, because humans are using the intelligence based on some patterns. But computers are not like that. Computers are using some algorithms and data structures to keep the data and store the data in uh, storages using some algorithm. It works actually. So that's the key difference between the machines and the human intelligence. Humans are using some patterns, but computers are using some algorithms or to store the data and retrieve the data. So you can see this AI is used heavily in many areas: speech recognition, space recognition, web searching, learning and planning, problem solving, gameplay. Like there are many areas this AI is been going to be used. So therefore, this is one of the key important part of the technology that you should know. What are the challenges with AI? Basically, the qualitative data. Like we know that there are some data which can be represented by numbers equal as qualitative data. As an example, emotions. When you say someone is happy, you can't represent by number. When you say someone is pretty, you can't represent by numbers. Like those are some of the key problems we have in the AI when the people are developing intelligence systems. How you can mathematically represent data which are having some not having some numerical values. And again, the computing power. Some instance to manage this large amount of data, like in the big data. The analysis cannot be done in the normal computers because the amount of data is very large. And then you have to have some very fast computers to process them actually. Another thing is the privacy and the security problems can be there, and some frauds can be occurred. So those are the challenges that are there in the AI. So when you're using the AI systems, we have to think about some privacy. Other aspects should be considered. Then none of the key components in the AI, we know this emotional computing. Idea is that, or we call as affecting computing. Basically, the idea is to identify the emotions of the human, and computer can intelligence determine the humans, recognize, interprets the human effects or intelligence, whatever that people, what we call as their feelings actually. The computer should be able to identify them. That is we call as emotional computing. The emotions like people are happy, sad, angry, like those emotions should be able to identify by computers. So these tools are already developed actually based on the way you are publishing some messages or the publishing some videos, images, or text. The computer can decide your emotions, whether you are in a happy mood or sad mood or like angry moods, like those can be detected. That is we call as emotional computing. So there are a lot of algorithms currently developed using these machine learning techniques where the human behavior or human emotions can be recognized by the computer systems. Then other key important thing is the AI is the agent. We know that agent is someone where you can allocate your task to do and return some results. So when you want to do some task, we can hire agent actually, and then you can hand over that task to the agent. Agent will do the task and return the value back to us. So in exam papers, there are many questions with this agent actually. But remember, this question initially when you read, it looks like very complicated. But actually, if you realize, you have to draw some diagrams and others, but they are very simple questions actually. I will discuss these past papers later. Remember, these agent-based questions are very simple. They are not difficult. So the key thing you should know that these agents are kind of software programs someone developed. So basically, these software programs can get some inputs through the sensors. Basically, these agents are using some sensors to get the inputs. And this agent can process it and makes its own decision. So make some information or make some decisions automatically without human intervention. So that's the idea behind the agent actually. So here we want to build the intelligent agent. So we know this agent is someone where that agent will work on behalf of us. That's the agent actually. So whenever you want to do some task, you can hire the agent and you can hand over the task to that person that he will do that task and return the whatever the outputs that you want by the agent. So intelligent agent is someone. Also, we can allocate our task to that intelligent agent. Is a software-based program or application where you can hand over the task to the intelligent agent, and it can get some inputs by using some sensors and processed and give some outputs. So in that case, agent should be able to work autonomously. That means our human interventions are not necessary. It should be able to make the decision by himself. So then with the changes in the environment, agents should be able to react accordingly. So, and get the desired output for the relevant person he has handed over the task to the agent. So in the agent environment, basically we have these components. There should be environment, agent to work, and there should be some sensors to get the inputs, and there should be activators. Based on that, we want to make some actions. We want to do something like activators, and there should be agent. So like these are key components in the agent technologies. Now, when you take the environment can be a road or classroom, factory, hospital based on the application. So we can create an agent. As an example, we can create a robot to clean the house. In that case, he is working on behalf of us. So he should be able to identify what are the places that are not clean. He should be able to identify how does it move. When it is moving, if there are obstacles, he should be able to identify them. Like using the sensors, it should be able to identify them. And equally, it should move by the activators. So like there should be environment agent to work. And there should be some sensors, maybe some cameras, some microphones, GPS or infrared sensors, temperature sensors, touch sensors, like there should be some sensors. So that can be used to get some inputs for the given systems or agent, or maybe some hardware-based robot. So in that case, there should be sensors to get the inputs. And there should be agent. Agent is basically the software systems. So it can store the knowledge and analyze the information, make the decision by itself, learn from the experience, solve the problems. So these things should be able to do the intelligent agents because he should be intelligent. He should be able to look at the changes in the environment and take the necessary decision by itself without human interventions and use the previous knowledge to solve the problems. So like it should be something intelligent. And there should be some activators, maybe some wheels, motors, speakers, robot arm, printers like that. So those are the activators are the one which will do some action. As I mentioned previously, the example, a robot cleaning a room or house. Now in that case, there are some activators, maybe the wheels that are moving to clean the roads or clean the room. So then based on the inputs, and we should be able to move the robots and clean the room. In that case, it should be able to identify the locations that are not clean, and it should be able to identify some obstacle in the room, and equally it should move. So like there should be activators for that actually. So as an example, if you take the example of this, robot vacuum cleaner, let's say there is a robot vacuum cleaner. So it will clean the house. So initially it should be able to detect the places where there are dirts actually using the sensors. And then you have to create a map in the room to where it should go. And you have to find the path it should go in the room and clean it. And it should be able to identify some obstacles in the room. And you have to change the path. And it should be able to learn the while it is moving, should be able to keep records so that next time he can find out can be use the previous knowledge when you are traveling to find out the best route to clean the room. Like this is an example how agent can work. So this is an example. Similarly, there are many places where the agents can be used actually. What are the characteristics of the agent? Mainly the autonomy. Autonomy means, as I mentioned, it should be able to work without human intervention. It should be able to make the decision without human interventions, work independently actually. So in that case, robots should be able to clean the room without human controls. And reactivity, response quickly to environment changes. As an example, while it is moving the robot, if the obstacle comes, immediately you have to stop it. So as an example given here, the car brakes when the someone cross the road. So we have to detect it immediately and then make the actions. That is called reactivity. And proactiveness. So we want to find out the initiative. As an example, the Google Maps can determine the best route based on the traffic by using the previous knowledge. So that should be proactive. And learning ability. So we should be able to use the previous knowledge when you're going to solve the problems. So as an example given here, the Netflix can make the recommendations to improve the over the time that they have used previously. So like that, rationality. In that case, you have to find the best action. As an example, chess AI should be able to select the strong move. And goal-oriented behavior. So there should be a goal to complete. So these are some of the characteristics of the intelligent agents. It should be autonomous, reactivity, proactiveness, learning ability, rational and goal-oriented behavior. Most of the time we are using multi-agent. That means not only one agent, we use many agents. Because some practical applications, we need to have the multiple agents working together. As an example, if you are creating the agent systems for traffic management in the roads, in that case, there should be agents in the many places in the roads. When the traffic congestions are going to be started, we want to solve by communicating with the each agents throughout the area, not only one agent. So the collaborations is necessary, where the agent should be able to communicate with the others. So in that case, multi-agent means basically two or more intelligent agents that are working together to solve a complex problem. So just keep in mind, there are in the practically, we cannot use a single agent. We have to use a multiple agents to solve some of the complex problem where they are in the distributed environment, not only single location. What are the characteristics of the multi-agent systems? There are multiple agents, not only one agent. So they are working together to complete the specific goal actually. Autonomy should be there, as I mentioned previously. They should be able to work autonomously without human intervention, should be able to make the decisions. And not like the single agent, multi-agent only should be able to communicate with each other because they are working or they are making some decision based on the others' inputs also. Therefore, they should be able to communicate with each other to complete the given task. And they should be able to cooperate. And the coordination should be done because there are multiple agents. In that case, that coordinations can be done centrally or decentralized manner. You can make the coordinations. Should be able to solve problems that are there in the different parts working together to complete specific tasks. Adaptability means some instance when there are multiple agents are working together, maybe suddenly one agent is crashed. In that case, you should be able to complete the task or adapt to the given environment changes. So that is equal to adaptability. Like these characteristics should be there in the multi-agent systems. What are the examples where the multi-agent systems are going to be used? You can see the healthcare, hospital management, patient monitoring, and transportation like traffic management, as I mentioned, the agriculture. If you are going to manage very large farm, in that case, multiple drones are going to be used to determine what places we need to have the fertilizer. like multiple agents can be used, and manufacturing industry robots, where there are multiple robots working together to solve the problems. And the bankings to detect the frauds, we can use the multiple agents running the machines. Smart cities, traffic management, energy management, waste management, those can be done with the automated robots that are there inside the smart city. So, like you can see, there are many places this multi agent can be used to solve the real world problems. Then the another key thing you should know is these Kensai systems. Then these Kensai systems used in basically in the Japan actually. So idea here is that it's a kind of AI systems that recognize the human emotions and use them to improve the product and services. You know that in Japan, vehicles, especially car, are manufacturing. Their products are very high quality. That is because of this actually. Mainly they consider about the users' emotions, whether they are happy, satisfied based on their products. They always look at the feedbacks given by the customers, and based on that, they make the changes to the product to provide very high quality product and services. That is the idea behind the Kensai systems. We have to look at the customer satisfactions and their feedbacks, and we have to make the new productions based on the previous feedbacks. So that is what is used basically in the Kensai systems in the Japan. And the man-machine coexistence idea is to, we know that currently we are having different intelligence systems. So we want to work together. That is because of the machines, humans should not be destroyed. And again, the humans should not destroy the machines. They should work together, coexistence. So that is basically the collaborations between the humans and the intelligent machines. So in that case, key characteristics are human and machines works together, and machines assist human in decision making and task execution. Human provides creativity, judgment, and ethical reason. It's like basically idea is to that both machines and the humans should work together. So the machines should not destroy the humans, and we want to make it solve some problem easily and for the better environment for the humans by using the machines. That means both should work together, helping to each other. Example, man-machine coexistence. You know that doctors use AI systems to identify some medical images to identify or some diagnosis some diseases. And if it is a manufacturing, the factory can use some robotic arms to make the work more efficient and faster and safely can be done. And education, you know that AI tools can be used by the teachers to provide personalized teaching methods for each students. Transportation, you can use different algorithms to find the best route. Like you can see, the machines and the humans should work together and get the help from the machines to solve our problem much more fast and much more easier. Therefore, both should work together. One should not destroy the other one. The ubiquitous computing idea is to have everywhere computers. So the thing is actually we can use whatever sorry. So whatever the things that are there in the environment can be utilized as a computer actually without any specific location specific device. We should be able to use everything. Every environment should be able to used as a computing devices. So that's the idea behind the ubiquitous computing. Everywhere, anywhere you can use thing as a computer. Example is smart homes. So smart light, smart thermostats, like smart security systems and smart watches, smart city, healthcare. Like you can see, you can use whatever the resources that are there in the environment to work as the computers and then provide the better services to the human. Then the another key area that was there in the computing is evolutionary computing. So this is actually one of the branch in the artificial intelligence where they look at the biological evolutions, the Darwin's biological evolutions actually. The idea is that we know that we have different generations from one to another. The idea is to that we want to have the best generations. Now in the biological evolution, the people are thinking the good people will come back to the world again, but the bad people will not come back. So that's the idea they have in this biological evolution. Similarly, here we have the one generation. Idea is that we have one generation. From that, we want to find out best people. We have to find out who are the best people. And then you have to select the best parent. And then you can get the children of the best parents. For that, actually, mathematical computations we use here called as a mutation in the crossover. So those are some mathematical operators that are used for the inputs. So idea is that we have a population. From that, you select the good parents, and with that good parents, we get the good children actually. And those children will be used for the next generations. Like this, go in a cycle. When you go in a cycle after some time period, we expect we have very good children. That's the idea here actually. So in this one, to do some uh, changes to the inputs, we use the mathematical operations we call as mutation and crossover. Those are some mathematical operators that are used with the binary values. So idea here is that we have initial population, and based on the fitness function, there is a function which determines who are the good, who are the bad actually. Using the fitness function, you can find out the good parents. And by using these good parents from the first generation and create the new generations. Using that good parents, you can give generation new generations by using this mathematical operation called as a crossover and the mutations. With that, you get the new children or new populations. And this will go in a cycle. When you go in a cycle, what happens? We accept after some time period, we have the very best population. That's the idea behind what we call this genetic algorithm. Sorry, the evolutionary computing. One of the key algorithms that are used in the the evolution computing is the genetic algorithm. So just keep in mind, the idea is that biological evolution, we expect the good people will create another set of good people, and the bad people will not come back to the world again. Good people again come back to the world again. So that's the idea behind this process actually. So here basically we take the initial populations and then find out who are the good, who are the bad using this fitness function. And by using them, actually, you can create a new generations. For that, you have to use some mathematical operations like mutation, the crossover. And then that new generations, we assume they are much more better than that previous one. And this will go in a cycle. After going more cycles, you realized you get very good population. That can be used to determine best solutions. Especially this can be used for uh, very large problem, complex problem to solve actually, especially when there are many solutions. Out of that, you have to find the optimal solution, best solution. For that, actually, we can use like route optimization and some robot path planning, some machine learning algorithm, some scheduling. So for that, actually, we want to determine best solution. There are many solutions. You have to find the best solution. So in that case, you can go in many cycles and find the best solution. This can be done with the this evolutionary computing. So one of the algorithm that are used in this evolutionary computing is genetic algorithm. So remember, this is the main algorithm used in the evolutionary computing to solve a complex problem where you can get very accurate solution, because that is used in the previous concept I have to explain to you previously. You have the initial population. With that, you select the good people using the fitness function, and then they consider as a parents. From that, you get the new childrens by using these mathematical operators called as a mutation and the crossover. and then we assume these children are much more better than the parents. And this will go in a cycle again and again. When you go in a cycle, at the end you get the population, new populations that is much more accurate, much more better. So that's the concept here actually. So we initiate with the initial populations and then use a fitness function to determine who are the good, who are the bad. And then once you selected them, you do some mathematical operations to generate the new generations. And this will be repeated again and again until you get the optimal solution or best solution. So therefore, remember this genetic algorithm can be used to solve very complex problem where there are many solutions. As an example, finding the best route. Let's say from Colombo to Anuradhapura, there are many routes, many paths, but we want to find out the optimal best path. In that case, this optimal solution can be determined by using the genetic algorithm. Like there are many places we can use genetic algorithm. Another key research in the computing or trends is a quantum computing. This is another research group who are doing the research works to make the quantum computing. It's advanced computing techniques. So here the main thing is a quantum. So idea is that actually normally you have the bits 0 and 1, but here we have a special bit called as the qubits. So here the qubit is something in addition 0 and 1, you can have both values at the same time. Another key thing is a superposition actually. So they expect there's a superposition state where some tasks can be done very faster, which cannot be done in the normal state. Because in the binary you have two states, 0 and 1. But in the quantum computing, they define a super state where we can do something much more faster, much more quickly, which cannot be done in the normal state. As you know that some people can go to the super state by doing the meditations. That's why some people do the meditation. We assume by doing the meditation, they can go to the super state. Once they go to the super state, we assume they can do something which cannot be done in the normal state. That's the concept they have here actually in the quantum computing. But still the research works are going on. But if this is completed, very complex tasks which takes maybe thousands of 100 years to process can be done in the few seconds. If this is successful, there's a issue or there's a problem with the security actually. Because some algorithms are developed in the security where our computer cannot process it. If the computer can process it, takes maybe to break some security algorithms, our computer may takes maybe some instance 100 years to process it. But remember that kind of work with the quantum machines can be done in the 1 second. There is a key problem if this is developed in the security. So here the basically very complex problems can be solved within a few seconds. So the process can be done very fast and can be stored very large amount of data very small locations. Like this is the key feature of the this quantum computing. And the last part is actually naturally inspired computing. We know that when the people are developing systems or machines, they always look at the natural things. As I mentioned previously, when the people are developing the AI, they have look at how our brains are working, and they want to imitate our brain functions to the machines. That is basically nature-inspired computing. At the same time, when the people are developing the aeroplanes, they have studied how the birds are flying, and they try to do the same thing in the aeroplanes, something like that. So people are studying natural things to develop the machines. That is we call as nature-inspired computing, or we call as the bio-inspired computing. As an example, genetic algorithm. That is how our human evolutions are occurred. Same thing is used in the machine genetic algorithm. In artificial neural networks, as I mentioned previously, when the people are developing the AI, initially they thought how our brains are working, how neurons are working in the brains, and they want to do the same thing in the machines. And some algorithms actually they have studied how ants are uh, creating the paths. That is equal as ant colony optimization to find out the best route. They have used Same methodology we are the ants are using to go to some location to one location another location. Like we are studying the patterns of the natural thing. This is equal as nature inspired computing. So these are the key parts actually you have to cover in this syllabus or this content. So then next time actually I will try to come. I will complete the other parts. Basically, the questions related to this part will be discussed probably this week or next week. This is very easy lesson. Just go through that and easily you can earn the marks. So normally the exam paper you get the questions from unit 12 and unit 13 and unit 11 IoT and this one and the businesses, three of the parts together. So then I will complete the IoT parts also, then you can easily get through this part for this question. This is not a difficult question, therefore definitely have to select it. Sometimes it looks like very complex based on the diagrams and others, but this is very easy lesson. So easy question in the exam paper. So I will discuss the questions next time and then you can get the good marks. Thank you for joining.